First example of the rational equation, a rational function worksheet. The first thing I probably want to do with this, I take a look at it, and then I probably want to graph it. Let's remember that when we graph, we put everything on the top in parentheses, then we put a division sign, and then we put everything in the bottom in parentheses as well. So we have one quantity divided by another quantity. All right, let's take a look. All right, so there we have a nice graph. Obviously, there's a vertical asymptote that looks to be at -1. Just for giggles, let's take a look at the table. And if we look at the table, we see right there, oh, whoa, there's a hole at 3. All right, well, that's what the calculator says. Let's see what we can figure out. The first thing we need to do is probably factor this. So that's going to be x minus 3. And if I take a look at this, let's see, that's going to be x minus 3 x plus 1. X squared, that looks good. Good. All right, so we can see, write the domain. X cannot equal 3 or -1. Those values don't exist. Write the ordered pair for any removable discontinuities. Well, this would be a removable discontinuity or hole. So if I were to factor that out, I would have 1 over x plus 1. So I put f, so this is a new function, and if I put the whole coordinate 3, the x coordinate in, it's going to be 3 and 1/4. Equation for any vertical asymptotes, x equals -1. That's a vertical line. Equation for any other asymptotes. This means horizontal. So if I look at this, I compare top heavy, bottom heavy match. This is bottom heavy, and if you recall, bottom heavy means y equals 0. Describe the end behavior of f. The limit as x approaches -infinity, so as it goes all the way to the left, it approaches 0. And as it goes all the way to the right, it approaches 0. Good. Compute the x-intercept. So basically what that means is I need to get y equal to 0. So that's the top. So when y equals 0, what's the function? If I look at these, basically, as long as I don't do anything with the bottom, if I don't find 3 or -1, if I make any 0 over any number, in other words, 0 over any number k is going to be 0. So all I have to do is set the top equal to 0. Yes? Well, in this case, however, 0, the top is also a hole, so there is no x-intercept. Right? I would set the top equal to 0, x would be 3, but then I would double check the domain. 3 isn't in the domain, so there would be no x-intercept. Compute the y-intercept, that would mean x equals 0. And if x equals 0, that's going to be -3 over -3, or when x is 0, y is 1. All right, now to the fun part, the graphing. Let's go right back up. Let's start the domain. Vertical asymptotes, -1. So x equals -1. We intercept at, we have a horizontal asymptote at y equals 0, and we intercept at 0, 1. So this would look roughly like that, and we need to label that point 0, 1. Complete.